So if I'm looking at problem 3, the first thing is, again, what does x represent in the triangle? So this is wanting to know, is it a leg? Is it the hypotenuse? So take special note of where the right angle is. The right angle is made up of two sides of the triangle. There's one side of that right angle. There's the other side that meets at a right angle. Those two are the legs. The side that I did not just identify, the side that's across from the right angle, that's the hypotenuse, which is what x is. So if you are finding the hypotenuse, you are finding the c portion of that Pythagorean theorem. A squared plus b squared equals c squared, where a and b are the legs. So that's what I'm going to do. I'm going to say the first leg squared plus, now I need to square the second leg. If you write it like this, which a lot of my geometry students do, you're going to get it wrong. Because I don't just mean, oh, square the number that's closest to you. I mean that entire leg length needs to be squared. And that's going to matter because if you remember when we talked about multiplying radicals, we said that if you have some radical expression squared, it means to multiply it by itself. So where am I going to do this? Let me try and come off to the side here. So if I'm taking 2 root 2 times itself, that means I have two coefficients to multiply together. 2 times 2 is 4. And I have the numbers underneath the radical to multiply together. Root 2 times root 2 is root 4. So there's a regular 4 here, but 4 is a perfect square. The square root of 4 is the number 2. So when I take 4 times 2, I have 8, and there is no more square root anymore. So if you take 2 root 2 squared, you should get 8. If you are using a calculator and you don't use the parentheses, you will not get 8, and it's exclusively because you forgot your parentheses. So that turns out to be 8. I also need to square my root 6. So you could go ahead and do the thing where you write it twice. Root 6 times root 6 is square root 36. That's a perfect square. It's 6. You could do that. Or you could just remember when we solved by square roots, we said that a squared cancels out a square root. I didn't do that here because I need to not only cancel that square root out, but also square this, and students just tend to not do that right. So anytime I have two things being squared, I write it twice like that. But if it's just a single thing being squared, I am perfectly comfortable just knocking out that square root. So the left-hand side of our equal sign ends up summing to 14. Since we're solving by square roots, I have something squared. I'm going to get rid of it by square rooting. I'm going to find my answer for x. Now 14 is not a perfect square. If you ask yourself what divides into a 14, you are not going to get any pairs, which means square root 14 is as simplified as it gets. However, you should have considered the two solutions of plus or minus. Except when we talk about the length of a side, you're never going to have a negative length. So we will have to throw that back out. When you do an algebra problem, don't forget the negative solution. The exact answer for the length of x is square root 14, and our unit here was yards. If I want the approximate solution, I'm going to go to my calculator, which I guess I could show you. If you have, oh, do I not have a calculator on here? That's annoying. If you have an Apple device, you might be used to your calculator just looking like this, but if you turn off your screen lock rotation, and then you can turn it sideways, then you should be able to type in 14 and then say that you would like to square root that answer. If you're not seeing the square root, push the second button. Nope, square root should always be there. So 3.74-ish. Let's see what I'm supposed to round to. It says to the nearest tenth, so it would be 3.7. The 4 makes the 7 stay the same. So that's my approximate length. Next, I want area. Now, when you do area, the formula for the area of a triangle is half of the base times the height. So I need to find a base and height, and when you talk about anything in geometry, base and height are not top and bottom. Base and height are things that make a right angle, which, what do you know? We already identified the things that make the right angle. We said this leg and this leg make right angles. So that's going to be our base and our height. our area will be found by taking 1/2 one leg, which is a square root 6, times the other leg, which is a 2 square root 2. And now we're back to the lesson on multiplying radicals. I'm going to multiply the coefficients, the numbers on their own without a radical, which is a 1/2 and a 2. Half of 2 is just 1. So I'm just going to put a 1. And then I will have inside the radical a 6 times a 2. So I'll have square root 12. I'll come off to the side and make my factor tree of 12, looking for prime numbers. And instead of square root 12, I can write that as 2 times 2 times 3 under the square root. Pairs make perfect squares. 2 times 2 is the number 4. The square root of 4 is a 2. I didn't solve by square root, so I don't even have to consider the plus or minus. My answer is just going to be 2 square root 3. And since this is area, we have square yards. And it says exact area, so I'm not going to pull out my calculator. I don't care about the rounding for this one. So, yes, complicated with the radical, but that's kind of like the basic type of problem that we're seeing here, where you're missing some side, figure out are you missing a leg or a hypotenuse, and do the Pythagorean theorem. Number 4 is where it definitely gets more complicated. So for number 4, we're supposed to find both x and y, and it says simplest radical form. And we kind of got a mix of things going on, but I do want to point out that I need to care about where this right angle is. So the right angle is here, which by the way means there's also a right angle here. So it's kind of like we have two right triangles glued together. So I'm going to focus on this right triangle, specifically because in this right triangle, we know there's a side length of 7, we know there's a side length of 5, I don't know this side length. If I would try the other triangle first, I'm saying I'm trying to find x. I know there's a side length of 9, but I also don't know this. I don't want to have two things that I don't know. That's just making my life more complicated than I'd care to. So again, I'm starting in the triangle on the left. It is a right triangle because I see the right angle. So I need to ask myself, well, what are my legs? So the right angle is made by this bottom length of 5 and this vertical length of x. Those are our legs. So a squared plus b squared will be the x squared and 5 squared. The side across from the right angle will be our hypotenuse, will be the c term, so I'll set it equal to 7 squared. So I'm going to go ahead and square those numbers so I can simplify this. I'm going to attempt to solve by square root, so I want everybody off that x squared side. I'm going to subtract 25 from both sides, which gets me 24. I'm going to solve by square roots, but that's not a perfect square. So I need to think of what divides up into a 24. So I'm looking for prime numbers. I'm just going to start with 2. Lots of ways to break apart a 24. This is my choice. So instead of square root 24, I'm going to have square root of 2 times 2 times 2 times 3. And pairs make perfect squares. So instead of square root 4, we can simplify that to just a regular 2. 2 times 3 is 6. And I'm going to drop that plus or minus because we only need the positive solution here because I'm talking about a side length of a triangle. So I now know that x is 2 root 6. So in my picture, I'm going to squeeze in right here. This length is 2 square root 6, which is helpful because now there are 2 side lengths I know in that triangle on the right. I'm going to change colors real quick. So in this triangle here, it is a right triangle that I poorly traced. It is a right triangle. We have 2 square root 6. We have, I'm going to just call this, what am I going to call it? I'm going to call it z. So this length from here to here, I don't know what it is. So I'm just going to make up a variable for it. 9 is across on the right angle, so it's going to be our c term. It's going to be the hypotenuse. So we're going to find z. Now, I just made up a letter. The question asks for y. What I want to point out, y starts here and ends here. So y uses this 5, but it also uses this z. It's 5 and z put together, which means, in other words, y is equal to the length of 5 plus whatever the length of z is. So if we can find z, we can find y. So I'm going to find z. So in that right triangle, I already said that y is the hypotenuse, so I'm going to set up my Pythagorean theorem where I'm going to have my legs squared. I'm putting the first one in parentheses because it has a coefficient and a radical, and I don't want to do it wrong. Plus z squared, and it's set equal to the hypotenuse squared, the side across from the right angle. Now I need to square these things. I'm going to come off to the side. Squaring something means to multiply it by itself. 2 times 2 is 4. Root 6 times root 6 is square root 36. And the square root of 36 is regular 6. So that turns out to be 24. And that's going to be set equal to 81. So I've just squared those values, being really careful to make sure I was squaring correctly. So I'm going to subtract 24 from both sides. I'm going to get 57. And I want to say that 57 can be divided by something weird, but maybe I'm wrong. 57 might be prime. I can't think of anything that divides into it. So technically, when I solve, I have plus or minus square root of 57. I'm just going to leave it as the positive solution of square root 57 because it's a length, no negatives. So when I come back over here, again, there's no blank for z because I made z up. I wanted to know what x was, which was the 2 square root 6. I would like to know what y is. Now y, we said, is 5 plus z. We just said z is square root 57. Those are not like terms. So if I am forcing you to use simplest radical form, there's nothing else you can do. Y is just 5 plus the square root of 57. And I don't think there are any units in this problem, so technically these are just both units. So it's annoying to leave it in radical form, but it is more precise. You don't have to worry about rounding. If it's a real-life application, you'd probably want to carry these exact answers until the very last second and then round. But again, Pythagorean theorem, for the most part, can be pretty straightforward, but there are times like this where we can complicate it, so we probably will. Maybe not on an assessment, but we can have